rip, they tear, they scoop, they haul. They are among the biggest and strongest machines ever built. They are heroes in the most astounding construction projects in the world, and occasional culprits costing environmental destruction. Now, experience the power to move mountains with construction machines on Modern Marvels.
In Southern California, earth-moving machines are creating a new dam. In terms of cubic yards of earth moved, this project is 14 times the size of the famous Hoover Dam, yet it barely makes headlines.
We're located in Winchester, California. It's about halfway between San Diego and Los Angeles, and we're under construction of the largest earth-filled dam in North America.
The entire Eastside Reservoir project, including the East Dam and the West Dam, which we have, is approximately 150 million cubic yards.
The pipeline that comes from the Colorado River 248 miles to the east crosses the earthquake rift zone of the San Andreas Fault. Water District engineers figure that one day the big one will strike and they would need to have a reserve. The amazing speed with which this new reservoir is being built would not be possible without today's state-of-the-art earth-moving equipment.
Today's large mining trucks like the 785 Cat are so sophisticated that they tell and record everything for the operator and for the mechanic and for management.
We have water trucks out here that just absolutely amaze me. We haul 20,000 gallons per load. And what really amazes you is the way that the computer programs and so much of those systems are controlled by electronic modules and computerization, where we can download information to tell basically what that machine, the function of that machine for an entire 24-hour period. We never had that before. We thought we knew it all, but we didn't.
Huge Ingersoll Rand drills create holes 45 feet deep in the solid rock.
Fire hole.
After explosive charges are detonated, a Caterpillar shovel weighing 350 tons moves in and scoops up the earth and rock into enormous trucks which drive it away.
So every pass, he's putting 23 cubic yards into that truck.
And each cubic yard of rock weighs about 4,000 pounds.
He can load the truck in a minute and 15 seconds. 4 to 5 passes, depending upon the density of the material that he's loading.
All this equipment has enabled the project to move forward with fewer people on the payroll, since the machines can work far faster than those of a generation ago. But the price tag for this is high.
The trucks were $1.1 million. 5230 cost $3.2 million. The reservoir will hold 269 billion gallons of water. It's going to be 2 miles wide and 4.5 miles long.
It sounded big when we came, but day by day we're whittling at it, and it just happens. Not a problem.
The business of moving the earth is nothing new. If we look back far enough, human beings found it necessary to dig dirt with the first earth movers, their bare hands. Eons ago, some unknown inventors fashioned the first tools: a shovel, a pick, a hoe. This ancient Egyptian wielding a hoe is breaking ground for a canal.
We've got the major projects in the ancient times, such as the giant pyramids of Egypt, the Great Wall of China, and a lot of other projects. They were all built by thousands and thousands of laborers, toiling away without any mechanized means whatsoever.
One of the first steps forward in the development of earth moving occurred when some unknown dreamer got the idea of putting boards together between two shafts to form the first hand barrow. Not content with this arrangement, some inventor, probably in China, got the idea of attaching a wheel to one end, and the first wheelbarrow was born. In ancient Egypt, over 4,000 years ago, something resembling a sled was used to haul heavy burdens. Round sticks or logs were placed underneath it to diminish friction. Now, more dirt or big rocks could be hauled. Between 200 and 250 BC, the Romans started work on their vast highway system. 2,200 years later, the remains of the Appian Way still stretch south from Rome to southern Italy. Using similar earth-moving methods, the Romans also dug mines for metals, providing us with an early example of the possible dangers associated with disrupting the earth.
Those were very small mines, and the volume of material that they were moving was being done by pick and shovel and by burros and little carts, not by the kinds of vast machines that we're using today. And we know that we're getting acid drainage and water contamination still flowing today from mines that were dug during the Roman Empire in Europe.
The development of earth-moving tools was extremely slow. The same basic practical two-wheeled cart was used virtually unchanged by the ancient Egyptians, medieval British and French peasants, and early American farmers. With it, manpower could be augmented by horsepower and mule power. When the first Europeans came across the Atlantic Ocean, they found the Native Americans using baskets, some of the oldest means devised by man to haul earth. The large mounds left by tribes throughout eastern North America, some of them hundreds of feet high, were probably built with the aid of baskets. Around the time of the American Revolution, earth-moving tools began to change. In a few decades, the Ames family of Massachusetts transformed the shovel, mankind's basic earth-moving tool for thousands of years. The patriarch John Ames, an ambitious blacksmith, began producing shovels in 1776. His son Oliver relocated their forge on the Taunton River at Northeastern. Their Old Colony shovel was 4 pounds lighter than its British competitor. Although it looked like its handmade ancestor, this shovel was factory-made, featuring steel plate with welded iron straps. By the 1840s, Ames shovels were forged at 2,000 degrees in sophisticated furnaces. Soon, Ames was one of the country's first industrial dynasties. The plant turned out 20,000 shovels a year, shovels that went to work digging the Erie Canal across New York and gold in California's foothills. The company prospered, and the rest of America charged forward into a new age of industrialization, which no one could have imagined.
The largest tires currently manufactured for earth-moving dump trucks are made by the Bridgestone Corporation of Tokyo. They measure 12.5 feet in diameter. Construction machines will return in a moment on Modern Marvels.
The year was 1836, and the Erie Canal was under construction across upstate New York. A new digging tool was invented by some unknown Yankee. At the front, he placed a strip of iron as a cutting edge, and the device, pulled by draft animals, scraped up loose dirt and rocks. Hence the name drag scraper, the granddaddy of today's more sophisticated machines. Meanwhile, one of the transportation dreamers who spearheaded the canal, Robert Fulton, also paved the way in harnessing steam power to machines. His Claremont was the first to steam up the Hudson. Steam power was soon utilized in earth-moving as well.
The first earth-moving machine was a machine called a steam shovel. William Otis was a young engineer, aged 20, and at that time he was thinking about better means of replacing hand labor and moving earth more efficiently. And he developed this new machine called the Yankee Geologist. And it's quite surprising to see pictures of that old machine and look at the modern machines and see how similar they are in overall appearance.
The Ames Shovel Company had prospered, and Oliver Ames had turned the business over to his sons. Oakes Ames provisioned virtually the entire stock of shovels and tools for the Union Army and became known as the King of Spades. Ames shovels moved the earth and entrenchments from Gettysburg to Petersburg. In 1865, Abraham Lincoln asked Ames to take over a foundering project to build a transcontinental railroad. Oakes became president of the Union Pacific Railroad, and his brother Oliver became its chief point man in Congress. Steam locomotives would soon cross the entire continent, but the rail bed upon which they traveled would be built with earth-moving technology that hadn't changed, using human sweat and Ames shovels. The Union Pacific Railroad opened the way for a whole new generation of farmers and earth movers. Stimulated by the railroad in the coming decades, steam power would also change the mining industry.
Doing this kind of digging started with John Henry versus the steam drill. Steam drilling equipment, steam excavating equipment, and then more and more mechanization and bigger machines.
New earth-moving equipment harnessed the power of water, enabling Western miners to extract ore at a quicker pace. By the 1880s, William Otis's steam shovel design was finally put into mass production by several companies. The most prominent of these were the Bucyrus Foundry and Manufacturing Company and the Marion Steam Shovel Company. The same technology was used in dredges, machines designed to scoop earth from the rivers and harbors of a growing industrial America. Meanwhile, early road contractors and railroad builders have long encountered earth-moving problems extending fills across swamps, bogs, and water holes. The Foley brothers hit upon the idea of pushing material ahead of a team of animals instead of drawing it from behind. The horses or mules were hooked up to a steel plate which they pushed. This was the early prototype of what was later to become the bulldozer. By the 1890s, the Austin Company of Chicago was leading the way in perfecting a dump wagon with a hinged bottom that could be used to quickly pour out the entire load. These early dump wagons soon evolved into dump trucks. Companies like Mack Trucks, founded in New York in 1902, and others were quick to seize upon the possibility of combining the internal combustion gasoline engine with the wagon design to produce new vehicles for harvesting, hauling, and dumping. Back in 1867, Swedish chemist Alfred Nobel invented a new explosive process that was to indelibly transform earth-moving.
Dynamite, if you may or may not know, is nitroglycerin that has been packaged in with sawdust or something to carry the nitroglycerin, make it somewhat safer. Dynamite made it possible to move mountains.
By the dawn of the 20th century, Teddy Roosevelt spearheaded the construction of a canal across Panama, connecting the Atlantic and Pacific Oceans by literally moving mountains, where French contractors had failed 20 years before. As an earth-moving challenge, the canal was made possible by the combination of the steam shovel and the railroad car.
The Panama Canal was dug from 1904 to 1914, and at that time the largest and most modern steam shovels were used to build it. The transportation of the material was rail transport. They laid temporary rail tracks, and rail cars were used with steam locomotives to haul the material away from the major cuttings. And there were as many as 102 steam shovels used on that project. These steam shovels were made primarily by two manufacturers, Bucyrus and Marion. And as we all know, the canal opened on time in 1914 and has been a major seaway ever since.
Just as digging on the canal got started, an epic-making breakthrough occurred, and it began in the farm fields of California. Benjamin Holt came west in 1883 and set up shop in Stockton, California. His lifelong rival, Daniel Best, was a gold miner, hunter, and miller who tramped all over the West before settling in San Leandro. Unlike the flat plains of the Midwest, California's topography called for an improved combine that could bring more marginal land under cultivation. Holt came up with a new kind of side hill harvester. Best picked up the challenge, and soon the two were locked in a contest to see who could turn out the most gargantuan machine. As their rival machines went into action, they boosted wheat production by millions of bushels.
The early tractors were, just huge. You'll see pictures of ones with huge A-frames built and extended wheels, which of course meant that when you got those stuck too, it was just a bigger job to get them out.
Bigger wheels were no solution in the spongy soil around Stockton in the rainy season.
Holt is credited with coming up with the idea that if you could have like a set of planks that just laid themselves down in front of you, spread your weight out so you could stay on top of the bog, developing the first track layer system.
Holt and his men removed the wheels from steam traction engine number 77 and installed a pair of new track units. The date was November 24th, 1904. A temporary solution to a local problem would soon be multiplied millions of times.
They put a set of tracks on a steam tractor, which was sold to a company down in Louisiana in the marsh down there. And the workers down there said, well, that looks like a caterpillar crawling along, and hence the name stuck. And so Holt's tractors became known as the Caterpillar system.
Holt and Best, always rivals, now intensified their competition, each company perfecting its design to outsell the other. As the popularity of their machines caught on, one famous artist even suggested the crawler as a commuter's answer to muddy roads. Holt and Best, talented inventor entrepreneurs, not only mastered the art of production, but also used new techniques of salesmanship to sell their machines throughout the world. By 1910, earth-moving machines were being exported everywhere, from Russia to Indonesia and Argentina to Hungary, launching a new era in earth-moving.
The largest Caterpillar-driven transport is the 131-foot-long Marion 8, used to carry spacecraft to their launch pads at Cape Canaveral. Fully loaded, it can weigh up to 9,000 tons. Construction machines will return in a moment on Modern Marvels.
Benjamin Holt invented the Caterpillar tractor for peacetime use, but its development was propelled forward by war. Even before America entered World War I, General John Blackjack Pershing used Holt machines to supply his troops as he pursued Pancho Villa across the Mexican border. Crawler tractors replaced pack trains to haul supplies to U.S. forces. August 1914, as war loomed over Europe, British General E.D. Swinton proposed building an armed land destroyer on a Caterpillar-type tractor base. The young First Lord of the Admiralty, Winston Churchill, was quick to see the potential of this technology to create a formidable new weapon.
Actually, the British Army took the concept of track layers seriously, and the Germans did not. The English sent Swinton over to visit the Holt facility, and they rapidly developed what was become known as the tank. The tank got its name in an interesting way. The English, of course, were trying to be secretive about their new weapon that was going to end the war in the trenches, essentially. And a passerby asked what, all these machines that we're laying out there, and the comment was, they're water tanks for Mesopotamia.
They weren't water tanks, of course, but the name endured. A special tank was presented by General Swinton to Holt in April 1918 in appreciation of the great service rendered Great Britain by the Holt Manufacturing Company during the war. The dictates of combat also accelerated the development of everything from large cranes to giant steam shovels. A young entrepreneur named Pauling teamed up with a German immigrant in Milwaukee named Harnischweger, and together they founded a small company that would eventually become Giant P&H, the world's largest manufacturer of power shovels, huge excavators, and hydraulic drills.
War is a pretty good money-making proposition. You know, certainly Holt and Best got rich off the idea, but you know, after the war, the markets got a little thin.
The pressures of overproduction, huge unsold inventories, and canceled war contracts led Holt and Best to bury the hatchet and make peace as well. Within a few years, the two companies merged, but they kept the winning Caterpillar trademark, which soon created its own special fraternity.
If you're a good operator, you would be called a cat skinner, which I think kind of denotes the popularity of Caterpillar equipment. There were a lot of other manufacturers, but you know, when you say Caterpillar, that's kind of generic for any crawler tractor anymore.
After the war, improved mechanization signaled a new era of American road building. Millions of federal and state dollars poured into new roads for the Tin Lizzies being churned out by Henry Ford and other auto manufacturers. In the 1920s, a new generation of improved bulldozers, scrapers, excavators, and rollers changed the look of the American countryside. The first self-propelled road graders appeared just prior to 1920, and as road construction boomed, these new tools grew in weight, power, and popularity.
This is a Caterpillar 60, and it's, you know, this built a lot of America. It's the last of the big gas burners up through the 20s. This one was built, I believe, 28 to 32, and it's, you know, it's very typical of earlier Caterpillars. Big low RPM gas engine, simple, very rugged.
One returning war veteran, Bob Letourneau, came back to California broke and in debt. But he borrowed a Holt tractor and began to design a new kind of earth scraper. With each refinement, Letourneau perfected his scraper. Before long, he was making big rigs like this 1929 Highboy, equipped with enormous steel wheels, being pulled by a Caterpillar tractor. Later, in a major breakthrough, Letourneau realized that big pneumatic rubber tires led to increased speed and greater hauling ability. So by the early 1930s, a new generation of scrapers and haulers were going to work.
He didn't start small and then develop into larger machines. Very often the first machine of a type he would build would be the largest ever built.
Letourneau's company was to prosper and grow over the next 40 years, fueled in part by the development of a revolutionary new kind of engine, the diesel. Early prototypes of this new motor had been around since 1893, when a European engineer, Dr. Rudolf Diesel, confidently took out patents on his new engine design, predicting it would double the power resources of mankind. Diesel fuel was much cheaper than gasoline, but lightweight diesel engines were not available for use on earth-moving crawler tractors until the 1930s. Eventually, an improved method of road construction would lead by the end of the 1930s to the first of America's new superhighways, the Pennsylvania Turnpike. Contractors' fleets moved 26 million cubic yards of Pennsylvania earth. This new divided road was a glimpse of things to come. Other, even more gigantic earth-moving projects were part of Franklin Roosevelt's New Deal. In response to the grave unemployment of the early 1930s, the new president was determined to use government to put the country back to work. He and his administration embarked on a series of earth-moving projects that dwarfed everything that came before them. A great new dam took shape in Black Canyon on the Colorado River between California and Nevada.
We stood behind Boulder Dam that was being constructed then, just before they closed off the diversion tunnels. And so I was a young pup, a young kid, of course, and I got to see equipment that I couldn't believe. It was uncommon. A lot of it was made for that job and that job only. And it was one of the wonders of the world. It would probably equate with the Egyptians building the pyramids and so forth. Then you saw these huge, huge trucks that carried not only debris and, you might say, blasted rock or dirt, but they also carried huge pipes for the downside and the intakes of the power plant. It was truly amazing.
Older style trucks were completely inadequate for a job like this. An entirely new generation of Mack trucks was designed with ribbed bodies, curved inward at the bottom to withstand the impact of huge rocks.
The company of Mack developed one of their famous trucks, and these trucks were chain drive, very strongly built, and they were really the first trucks designed solely for off-highway use as opposed to the lighter duty highway type trucks.
This same mastery of earth-moving technology went into building the Grand Coulee Dam on the Columbia, and hundreds of new dams that dotted the Tennessee Valley and other parts of the country. Earth movers traveling from job to job kept in touch, forming a loose network of friendships that remain strong today. No one in the 1930s knew how important the new dams would become a few years later. Without their electric power, America could not have transformed itself into Roosevelt's arsenal of democracy in the epic conflict that was looming just beyond the horizon. With the invention of steam power and then electrical and diesel-powered equipment, man's ability to move and transform the Earth accelerated enormously. But this enhanced power also opened the door to new problems and unforeseen conflicts.
The very earliest stripping shovel used in coal mining was developed by the Marion Steam Shovel Company. They came out almost every 2 or 3 years with a bigger machine, and by 1923 they had made the world's largest machine ever to move on land. That was quite phenomenal because it was built in the days before the era of welding. This huge machine was built using rivets. This was quite a major breakthrough.
Now, a drag line is a large piece of machinery, but instead of having a dipper bucket in the front that you would dip up the rock and ore, you have a huge boom or a large boom with a shiv wheel on the end of the boom and cables that go over that boom and attach to a bucket, and the bucket is dragged into the machine until the bucket is full.
When I was a child in a small rural community in Arkansas, just a few miles out of town, we had a strip mining operation. It was a subsidiary of a large national coal mining company. Back during the Depression, you saw that as a good job that paid $1 to $4 an hour, which was a big salary, big wage back then. And they saw it in one-dimensional, and that was pure economics. Nobody was thinking about the long-term effects of the damage this earth-moving equipment was doing.
But when John L. Lewis, head of the United Mine Workers, stood up to the big mining companies and their enormous new machines, the implicit question was, what is the price in human blood for all of this progress?
If we must grind up human flesh and bones in the industrial machine that we call modern America, we owe protection to those men first, and we owe the security to their families if they die. I say it, I voice it, I proclaim it, and I care not who in heaven or hell opposes it.
In the 1930s, economic depression and the struggle for global resources heated up as Germany, Italy, and Japan challenged the old rules of the game. Even before American entry into the Second World War, the earth-moving industry was gearing up for war production. Throughout 1940 and 41, heavy equipment was already going overseas to Britain and Russia. American military designers asked Caterpillar to design a radically new air-cooled tank. A few months later, a test model was ready. Soon, M4 tanks were rolling off the assembly line. This new diesel tank could use heavy oil and low-octane fuel, an advantage in hilly terrain. December 7, 1941, the Japanese attacked Pearl Harbor by surprise. The entire earth-moving industry went to war. War production reached a fevered pitch in coal mining, logging, and farming. Earth movers embarked on crash programs, laying new pipelines, building war material plants, and new highways. With Japanese forces on the move, Alaska was vulnerable to attack and invasion. The military saw a vital need for a highway to resupply Alaska through Canada. Work began on the Alcan Highway, the greatest construction project since the Panama Canal. It was dubbed the Road to Tokyo by the men who scrambled to build it.
It was built in only 2 short summer seasons. It was a major effort, and they forged through swamps and woods and creeks and pushed this road through in just a phenomenal pace.
By November 1942, the first Mack trucks roared north on the completed Alcan Highway to Fairbanks. In the Pacific Campaign, the U.S. mounted a strategy of island hopping, landing men and machines, quickly establishing a beachhead and moving on to the next battlefield. The Navy Seabees built bases and landing strips virtually overnight.
This is an international TD-14. These tractors were developed primarily for agricultural purposes. One of the interesting things, or certainly lucky things for us in World War II, is this heavy construction equipment is readily adaptable. Actually, there was very little change in equipment as it went onto the battlefield.
The importance of earth-moving technology was dramatically apparent. When American flyers needed emergency airfields in China to land their bombers after attacking Japan, thousands of Chinese peasants used the same age-old method of shovels and baskets to carve runways. Admiral Halsey summed it up when he said the 4 machines that won the war in the Pacific were the submarine, radar, the airplane, and the tractor bulldozer. Earth-moving equipment was just as important in combat in Europe. Following amphibious troops onto the bloody invasion beaches of Anzio and Normandy, huge bulldozers cleared mines and knocked out enemy pillboxes so battalions could move inland. The turning point came when the Russian army finally broke the back of the Nazi war machine. In the greatest tank battle in history at Kursk in 1942, 8,000 tanks fought to the death. In the aftermath, thousands of burned hulks, descendants of Benjamin Holt's California invention, littered the snowy Russian steppes. Back in America, companies like Bucyrus, Erie, and Marion manufactured earth-moving giants the likes of which had never been seen. By 1945, the giant dipper of one of these shovels could hold a Chevrolet truck or 9 men. With the demands of wartime production, enormous new excavators, drag lines, and steam dredges were developed that dwarfed everything that had come before. And this was only a taste of things to come.
The most powerful gantry crane is the Rayco crane at the Grand Coulee Dam in Washington. It once lowered a 1,972-ton generator rotor with an accuracy of 1.32 inches. Construction machines will return in a moment on Modern Marvels.
The economic surge that followed the end of World War II triggered another round of highway construction, mining and building with ever larger and more efficient machines. But along with progress came new concerns. Enormous strip mining machines were manufactured each year after the war. These super strippers got bigger every year through the 1950s and 60s. This colossal stripping shovel, the Big Muskie, manufactured by Bucyrus Erie to dig coal in Ohio, was the biggest earth-moving machine ever made. It was nearly 22 stories high, and with its boom extended, was longer than 1.5 football fields. Weighing more than 150 Boeing 727 jet planes, it used more electrical power than a city of 100,000 people. Concern grew during this period, however, that strip mining in coal was devastating vast areas of West Virginia, Ohio, and other states. There were no reclamation laws, and the land was physically not restored.
The problems with strip mining had been accelerating in the 50s and 60s in Appalachia, and yet it wasn't until in 1972 there was a failure of a dam that coal miners had built up on a hillside in a place called Buffalo Creek in West Virginia. And the material behind that dam all flooded down into the valley and drowned 125 people.
Shocked by this tragedy, Congress passed legislation regulating coal mining and requiring restoration of the open coal pits. But the large coal companies did not concede without a fight.
Nixon vetoed it because the coal industry said it would be the end of coal mining in America. Then Congress passed it again under President Ford, and Ford vetoed it again because he was listening to the coal industry. And then they passed it again in 1977, and President Carter signed it because he felt that this industry had to be brought under control.
The legislation had a dramatic impact on the coal companies. Responding to the new 1977 law, the companies changed their techniques and priorities. Some major strip mining machines, like the Big Muskie, were closed down. Even more important, the companies developed cost-effective ways to remove the topsoil and the overburden, mine the coal seam, and then comply with regulations to restore the land. Soon, most of the industry moved out of Appalachia to western states like Wyoming, where the coal was more economical to mine.
The biggest dragline working today is in the Powder River Basin. It's a machine called the Bucyrus Erie 2570 WS machine, and it has the name of Ursa Major, and it has a bucket capacity of 160 cubic yards.
Today in the coal mining industry, computers are used to plan the contours of the land. Once the coal seam is mined, a new generation of earth-moving machines restores the environment to a form resembling its previous condition. But the new regulations cover only coal. Other sectors of the mining industry remain unsupervised.
The only industries that I can identify for you which virtually get off scot-free are in the hard rock mining industry of gold, silver, quartz, all of those kinds of things, palladium, platinum. Those are all considered hard rock minerals. And reclamation laws are not nearly as stringent as they ought to be, and certainly not as stringent as they ought to be, considering the fact that they take this stuff for nothing and the taxpayers, as they say, gets the shaft.
Critics like Senator Bumpers and others say the old 1872 mining laws are inadequate because of the unprecedented scale of changes over the last few decades.
In the last 15 years, the mining industry, in fact, has cut its manpower demands in the U.S. by about 80%. So we now only employ about 50,000 people to do the mining that used to require 250,000 people, and yet we're mining metals at a greater rate than ever before.
Near Elko, Nevada, some of the biggest equipment on Earth works the enormous Betsy Pit mine, an immense and very rich $10 billion gold deposit. Huge trucks haul ore out of the pit at the rate of 240 tons a load. A decade ago, computer-coordinated equipment like this didn't exist. Using massive pumps, earth-moving engineers keep water from refilling the pit, improving the efficiency and speed of ore extraction. This same rapid development is seen in other parts of the country as well. Throughout central Florida, near Orlando, open-pit phosphate mines stretch far off to the horizon, where enormous modern hydraulic sluices pump out the mineral. The biggest man-made excavation on the planet is the Bingham Canyon Copper Mine in Utah. Copper mining has historically been one of the biggest of earth-moving operations. The ore volumes are very large, and they're spread out over wide areas. Wisconsin's 100-year-old P&H company recently completed a remarkable new behemoth. This earth-moving drag line, called the 9020, has a crane longer than a football field, moves on state-of-the-art walking legs, and has its own built-in kitchen.
One mining industry attorney I heard at a conference said, let's face it, gentlemen, we're not just impacting the environment at these sites, we're removing it. And that gives you a sense of the totality with which mining can come into a landscape and literally remove a mountaintop, turn what was a mountain into a huge open pit.
Due to this unprecedented ability to move the earth, industry leaders and policymakers face new challenges and new responsibilities.
One of the biggest problems from moving all of the material that these machines are pushing around at mines is what's called acid mine drainage. When you break it up so that it's no longer a big solid mountain, you release a lot of sulfur compounds in it. When it reacts with the air and with water to form sulfuric acid, then the acid flows downstream. It picks up other heavy metals and contaminants and carries them off of the mine site and into the rivers and streams around the country.
The political clout of the mining companies in this country is awesome. When you consider the magnitude of the problem that these people have created without paying the federal treasury a dime, and now the federal treasury, the taxpayers, are going to have to pay to clean up 557,000 abandoned mine sites. And while the problem is not as acute now as it used to be, the problem is still there.
With the extraordinary development of these new machines, the need for responsible public policy seems more pressing than ever.
The new earth-moving equipment gives us the opportunity to create bigger and bigger environmental messes, but it also gives us the opportunity to fix them.
In the future, new technology and the ongoing public policy debate will lead to enormous changes in the earth-moving industry. In the meantime, the people we call earth movers will continue to work and take pride in their amazing machines.
Hard drinking, hard cussing, hard working bunch, but I think all in all, a very moral bunch of people. You know, they're interested in building. They got that 1,000-yard stare, you know, they're looking off into the future. And I think a lot of it is knowing is what they're doing today, somebody's going to look at 20, 30, 50, 100 years down the road and going to marvel that what they did with the technology they had at the time, and how they could build something so durable to last over the generations.
The largest earth-moving truck is the Teres T-Tal 3349 made by General Motors. It has a capacity of 350 tons, and its cylinder engine delivers 3,300 horsepower. Construction machines will return in a moment on Modern Marvels.
Human earth moving has definitely accelerated in the past century or two, and is now comparable to all of the other erosional processes.
It all started so innocently roughly 400,000 years ago when Homo erectus started rolling big rocks around.
They were moving boulders into position to hold posts running down the middle of the dwellings, and these posts must have required holes dug in the ground. And so this is some of the earliest evidence that we have of human earth moving.
Soon we were digging holes, removing dirt in woven baskets, and digging out mud for bricks. We're still digging holes, but we're better at it now. A lot better. This is not a woven basket. It's a 320-ton Komatsu Haulpak 930E, currently the largest truck in the mining industry, though probably not for long.
There's already some manufacturers talking about 360 tons, and there's probably going to be 400-plus tons trucks in the future. It wouldn't surprise me.
Clearly, this is not your typical pickup. A man can walk underneath this vehicle without even bending over. The 6 tires have a radius of over 12.5 feet and cost over $30,000 each. The fuel tank carries 1,200 gallons of diesel.
Most highways wouldn't last very long with the types of weights that we're talking about in these trucks.
Neither would overpasses. This truck is 23 feet tall.
It's basically just like driving a big old house with a cab sitting on top.
Komatsu Mining Systems is one of about 6 manufacturers of these large off-road trucks. Their plant in Peoria, Illinois began as the dream of a man named R.G. Letourneau.
He manufactured scrapers, made his own welders, made wire rope, and basically founded this. So from that, we grew into off-highway trucks.
Letourneau kept his engineers on their toes.
He would go around the shop and some piece wouldn't work or wouldn't fit or whatever. He would either redesign it on the shop floor with chalk, or he'd have an envelope in his pocket and he'd draw it on the back of the envelope, and it'd drive the engineers nuts just trying to keep up with him, because those were the changes for the next machine.
Letourneau's first haul-pack truck was a 32-ton vehicle designed for use at mine sites, hauling giant boulders, tons of earth, or mounds of coal.
He'd make the truck short so it would have a short turning circle, make it maneuverable. But the major thing he did was that the truck weighed less than it carried. And all the trucks prior to the off-highway trucks prior to that weighed a lot more than the payload that they carried. There's a lot of efficiencies gained with that.
Trucks evolved from old dump wagons of the 19th century, designed to be able to lift and dump their haul of earth. With the advent of the internal combustion engine, companies like Mack improved on the horse-drawn wagons. Standard trucks that worked standard jobs, even giant projects like the Hoover Dam, were small enough that they could weigh more than their payload. But when the truly gigantic off-road trucks began in the late 1940s, their much larger payload capacity made Letourneau's lighter design much more practical. After Letourneau retired, the company passed through many hands, including ultimately Komatsu, which now builds a vehicle with 10 times the hauling capacity of Letourneau's first haul-pack. Things have changed since the days of blueprints on the back of envelopes.
I supervised 6 other engineers, and we're responsible for the design of the hydraulic systems on the trucks, as well as the brake systems, brake application systems, and final drive design for the large electric trucks.
The largest trucks are powered partly by diesel engines and partly by electricity generated by the vehicle itself. The diesel engine is connected to electrical generators. Energy created when the trucks descend a hill is stored in batteries on the vehicle. That stored energy is then used to power the trucks when they ascend hills, sending power to the large wheel motors. The trucks have no transmission.
Yes, it is more elaborate than your typical Ford or Chevy pickup.
The Komatsu plant looks like a boneyard for dinosaurs.
The assembly process for a 930 takes approximately 10 days from the time the frame is set in this building and the assembly process starts.
Steel that makes up the body can be 1.5 inches thick. The engine is 2,700 horsepower. The truck reaches a top speed of about 45 miles an hour. The volume of the bed is roughly 200 cubic yards. The vehicle is 27 feet wide and 50 feet long. Once the assembled truck is tested, it has to be disassembled and transported to the job site.
Typically ships by rail, requiring 3 rail cars to ship the wheels, the truck itself, and its components, but that does not include the bed of the truck.
Once on site, the trucks are in continuous use, 3 shifts a day, 365 days a year for the life of the vehicle, which is estimated at 15 years or more. That's around 100,000 hours of driving. Mines must really work the trucks to show a profit. A truck the size of the 930 costs over $2 million.
The name of the game in producing efficiently is asset utilization. When a customer, such as a large mine, buys a fleet of equipment, they're making a substantial capital investment, and they have to get every ounce of production out of that investment that they can get.
These trucks are used in all kinds of mines, from coal to gold, but they are most commonly used in open-pit copper mines. Having 8 or 10 giant haul packs is cheaper and more efficient than having 40 or 50 smaller vehicles.
In other words, it's more economically efficient to move ore with larger and larger machines.
And in an industry with a poor environmental reputation, these trucks produce less emissions per ton than smaller trucks and take fewer trips. The trucks are sized to match the shovels that do the actual digging on site, with optimum truck size being 4 passes or swings of the shovel per load. That's as much as 80 tons per shovelful. Big trucks like these have to be accommodated with special wide roads.
It costs a lot of money in a mine to build a road for the trucks. They're changing all the time because they're making the mine wider all the time. So they have to keep the roads up, and it's a big cost for them to do that.
And if you're driving a regular-sized vehicle, you have to watch out, because up in the driver's seat of a 930, the blind spot is enormous.
There are numerous incidents of pickup trucks being run over in mines by these trucks, and I will tell you, in a 320-ton truck, you can run over a pickup truck and not know it.
For now, the 930 is at the top of the heap for big trucks, literally towering over every other truck in the industry. Getting more out of earth movers means getting more out of the earth. For Komatsu and the other big truck manufacturers, that means designing bigger and bigger vehicles to get more ore out of a mine. For other earth movers, it might not be precious metals they're looking for, but literally tons of soggy muck. Next, giant dredges.
The Komatsu 930E haul pack truck hauls in one truckload as much as 600 standard pickup trucks. Construction machines will return in a moment on Modern Marvels.
The dredge Atlantic floats out in Charleston Harbor, pulling up muck from the bottom of the channel and loading it onto a scow which will haul it out into the ocean and dump it. Dredges clean up shipping channels so that today's ships, heavily laden with goods, will not run aground. This dredge floats 40 feet above the earth it's moving. The Atlantic is one of the largest dredges on the eastern seaboard, capable of shoveling 32 cubic yards, the equivalent volume of an average-sized bedroom.
This is a large job we're on now. It's about a $38 million job.
The job in Charleston is two-pronged. The Atlantic is scooping out muck that is shoaled in or migrated from one part of the harbor into the channel. It is also digging the channel deeper than before in order to accommodate ships loaded to deeper depths.
So we're actually doing about 4 feet of maintenance and another 5 or 6 feet of additional depth to increase the depth of the channel.
The Atlantic, owned by Norfolk Dredging Company of Virginia, is a sophisticated multi-million-dollar precision instrument using the latest global positioning systems and onboard computers. It wasn't always like this. Thousands of years ago, the Egyptians would swim to the bottom of the Nile with cloth bags to scoop up sludge. It was labor-intensive and required a lot of breath, but the Egyptians were able to remove silt runoff and muck that was filling in the river. As society began to depend more and more on shipping for trade, the need grew for deeper harbors to accommodate heavily laden ships packed with exotic goods from foreign lands. Maintaining these deep harbors and clearing out the silt and soil deposited by tides, agricultural runoff, and erosion became a daunting task. Mechanical dredging began around the 14th century in Europe and consisted of wooden planks chained together with buckets. The first steam-powered dredge appeared in 1804 and was the product of Oliver Evans, an American inventor. Steam engines would eventually operate buckets with 4 to 6 yard booms. Steel and the internal combustion engine would once again be the catalysts that would allow these earth movers to grow into monsters, though the job itself hasn't changed much.
Basically the same thing, just on a smaller scale, with wooden hulls or wooden booms.
Excavating channels isn't the only job a dredge can do. In a strange earth-moving hybrid, some dredges are used in the mining industry to look for precious metals like gold. This abandoned dredge high in the mountains of Colorado was used to dig its own pond, where it would float, loaded up with the big rocks it had just excavated. The rocks would sift down into the dredge, sorted by size, for it was the smallest rocks that the miners were seeking. In the smallest rocks was gold, 10 times heavier than water and more easily extracted than gold in the bigger rocks. Few of these old mining dredges survive, and fewer still continue to dredge for gold. The more traditional dredges built for widening and deepening channels certainly have grown up.
The process hasn't changed very much. Years ago, dredging was a simple business for simple people, using simple tools. And some of it has changed, but mostly what has changed is your positioning equipment, how you maintain your position. And now it's all electronic, all DGPS, all satellite control.
And that's not all that's changed. These dredging giants are a lot more efficient than the old wooden buckets ever were. With the size of the solid steel buckets the Atlantic uses, this dredge can fill up a scow that is able to hold 5,000 cubic yards of muck, or 157 buckets full in no time.
If you're digging in mud with a large bucket, big mud bucket, you could load this scow probably in 2 or 3 hours.
Even the scows are state-of-the-art.
It's the Cadillac of all scows. It's real heavy duty. When the scows are full, he'll take this one away. He takes it out to the ocean and bottom dumps it. The scow actually splits right down the middle and dumps it out to sea.
High above the scow in an air-conditioned compartment, the operator manages the bucket on a diesel crane with a 48,000-gallon fuel tank. The operator monitors a GPS system that tells him exactly where to scoop. Locators on the dredge beam a signal to a satellite overhead, which then tracks the dredge.
That shows me that we're online, that I'm set up to where I need to dig, and so forth all over the area. It's pretty easy. Once you, if you got everything spread out pretty good and you know what's happening, you can go about anywhere you want to.
Helping the operator keep the dredge in line is the dredge man. When the dredge has scooped up all it can in one section, the dredge slides down on a cable between anchored points. Unlike boats, dredges can't propel themselves. They are hauled into place by tugboats and maneuver around a site using anchors and chains.
The whole Charleston Harbor here, we've got it on our computer disk and everything, and we can pop it up at any time and see exactly where we're going to be headed to and exactly how to get to it and set up.
The entire job is sectioned off into stations, which can be completed in a 12-hour shift. The dredge scoops and then moves back and forth within each station until the area is cleaned out. With help from the computer system, this dredge can cover a lot of ground in a single shift.
Sometimes 200, 300, 400 feet for a shift. It depends on how much material we're digging.
The dredge uses different buckets, some with steel as thick as 7 inches for different situations.
If you were digging some hard clay or something like that, we'd have one bucket to go to, and then if we had some sand, or we'd switch buckets, a bucket that would dig that, and then you've got buckets for just mud.
The entire operation works with 4 to 6 person crews, shoveling 24 hours a day and maintaining the equipment.
If it's broke, we'll fix it. If it's not broke, we'll paint it.
Not surprisingly, the buckets occasionally bring up more than just mud and sand. If you can think of it, some dredge has dug it up.
Everything from cannonballs, shark's teeth that are as big as your hand, all sorts of things. Automobiles, airplanes, motorcycles.
But their main function is to scoop up earth, and lots of it, before it fills in again. It will take Norfolk Dredging about 2 years to dredge all of Charleston Harbor. When they finish, they'll likely have to go back where they started and repeat the process all over again. The rule that the shortest distance between 2 points is a straight line is one that has always propelled the tunneling industry. Instead of building a road around a mountain, you go through it.
During the early Stone Age, or Paleolithic period, people realized that they could dig using shoulder bones of oxen and things like this.
Archaeological studies reveal that some early excavations were 30 feet deep and 30 feet in diameter. But you can only go so far with the shoulder of an ox. By the 19th century, explosives, drills, shovels, and picks brought tunneling some sophistication. Tunneling and mining operations use these tools as their primary method of excavation for generations. In fact, the Comstock silver mines of Nevada and the Holland Tunnel are just 2 examples of the hundreds of jobs that use drilling and blasting to hollow out the earth. It's quicker than an ox shoulder, but it's not an exact science because dynamite isn't a surgical instrument, and it's labor-intensive because there's plenty of rock to remove from the side every time you blast or shovel or pick your way to the other side. But there's a better way. It's called a tunnel boring machine, and according to Heron Connect, one of its manufacturers, it is the shortest distance between 2 points.
It's basically like a glass cutter. It's pushed against the rock. As it's pushed against the rock, it forms an indentation. It's rolling, and then it creates fissures in the rock, which do the rock cutting. They started out in very small diameter. Early on, they were 12-inch diameter.
Now you can drive a train through the holes they create. Some tunnel boring machines even build the tunnel as they dig it.
Nowadays, particularly in the last 5 or 10 years, tunnel boring machines have developed what they call a single pass lining, which is gasketed, bolted, and its segments, if you take a circular tunnel and the installed segments, they could be in one ring, which could be composed of, say, 7 to 8 pieces, is installed directly in the machine as the machine is progressing. And as the machine progresses forward, then you actually have the permanent lining behind the machine, and the tunnel is basically finished once the machine has finished the excavation.
The tunnel bore works by gripping against the tunnel wall as the cutting head grinds away. The gripper slowly pulls the machine forward as the cutting head bores through the earth. It's like a giant can with one really sharp edge on it. It's much faster than the old drill and blast method, and much more precise.
It really depends on the ground conditions, and the soft ground we may only get around say 4 to 5 foot an hour. The ground is real hard, just the hardness of the ground may keep us down around 3 foot an hour. For the ground semi-soft, we can get up close to 12 foot an hour, if not exceeding that, depending on the diameter of the tunnel and the muck removing system.
And how does that compare to the old drill and blast method?
Well, I can compare it to the way we actually start the tunnels. Now we have to actually do some drill and blast. And historically, we may be able to get 6 to 8 foot a day. So we can usually do what they do in a day within 1 hour of actual operation.
The precision of a tunnel bore can actually save the client money.
One of the main advantages is that you get a cut diameter fixed all the way through. Your concrete cost, therefore, is almost a known. Where if you drill and blast, you have a lot of overbreak, your cost of your concrete goes up considerable.
That can amount to total savings on a job in the vicinity of 20 to 25% over drill and blast methods. The excavated material is removed in different ways depending on the hardness of the earth the bore tunnels through.
The material actually, as is excavated in a hard rock project, comes out through conveyor. It's passed through the machine. Depending on the system behind the machine, it can come out through a conveyor. It can come out through what they call muck trains, which are basically containers just bringing the muck out like a normal train that you would see.
In the soft ground machine, there's actually another way. We bring it out of the machine in almost a liquid form. We put a lot of water in there. The ground is cut up a lot finer, and then it goes out through pipes onto a conveyor belt or into a muck car. But we actually slurry it out from the cutting face itself.
The tunnel boring machines are much better for building tunnels in urban environments where explosives and noise and traffic tie-ups can be unacceptable. And they're much better for building small bore tunnels which are too small for people to actually climb into. Heron Connect manufactures all sizes of tunnel bores and currently builds the largest, a 47-foot diameter machine. The machines are manufactured at their plant in Germany.
The factory does the complete fabrication, the complete machining, the assembly. It's assembled in the shop, it's fully tested, and then it's broken down into shipping, and then it's shipped to the particular job site.
The assembly takes a little over a year, with the largest machines taking about 15 months. Those big machines can be 60 feet long, 400 feet including the earth removal systems behind them. And they can weigh up to 3,500 tons. Each machine Heron Connect builds is custom made for a contractor working a specific job. When the job is finished, the contractor might disassemble and store the tunnel bore, or sell it, or rebuild it for another project. These sophisticated drilling machines might appear to be the pinnacle in tunneling technology. But Heron Connect and the other 2 or 3 tunnel boring manufacturers in the world are planning even better machines.
I think the future of tunnel boring machines in particular is in automation. That one day you'll see a tunnel boring machine, large diameter, excavating below a city with nobody actually physically in the tunnel. The excavation will be occurring remote control from an office above the tunnel. All the lining will be done automatically. All the equipment brought into the machine will be done automatically, and everything can be controlled from the surface.
When tunnel borers push into the ground and pull earth to the surface, it's a great achievement. When a plow turns the earth upside down, it can be a disaster. Next, the plow that broke the plains.
Some estimates place the amount of earth moved by humans annually at 6 tons for every person on the planet. Construction machines will return in a moment on Modern Marvels.
Giant trucks and dredges and tunnel borers move massive amounts of earth every day. Far more than an average farmer could hope to move in an entire year. Farmers move just a little bit of earth, just a few inches, with a humble and unassuming plow. Yet that simple revolutionary mechanism helped contribute to a series of catastrophes in the 1930s, from which some are still recovering. The Dust Bowl. Drought, wind, over-farming, and the Great Depression conspired to turn what had been 97 million acres of lush farmlands into a desert. The fiercely independent and industrious pioneers who settled the prairie would have their hopes dashed as wind blew away the earth, blew away topsoil, even blew away the settlers, some of whom escaped just ahead of black rollers that blotted out the sun.
You'd run for cover, and after a while you learn not to worry about the chickens and the cows, but to run for cover yourself. I interviewed people that said they would put in clotheslines or ropes between the barn and the house, or between the outhouse and the house, because you couldn't find yourself around. It was like being in a black blizzard.
Throughout the history of agriculture, which began in Mesopotamia in the 9th millennium BC, a few key technological concepts have had a huge impact on civilization. One of the earliest was the invention of the plow.
Early plows were made of wood, and as iron became available and was used for the actual cutting edges of the plows, that made plowing somewhat more efficient.
2 technological breakthroughs would have a great impact on the Dust Bowl. One was steel, which was more readily available during the mid-19th century.
A steel plow that could break that really tough prairie sod. And of course, once you broke it, it didn't heal. It was scarred forever, and the wind could get to it, and the elements could get to it.
The other was the internal combustion engine.
Tractors were starting to be used in the 1920s. Farmers could now plow 50 acres of land in a day rather than 3 that they were doing with horses.
The Great War created an enormous demand for wheat in 1914, and prices skyrocketed. Before the widespread use of motorized plows, just as the virgin prairie of southwestern Kansas was settled, farmers plowed under the grass and sowed the land with wheat. Acre by acre, the earth was turned upside down by the farmer and his plow, multiplied by thousands of farmers with thousands of plows on millions of acres of once virgin prairie.
They called themselves sod busters, and they bragged about breaking the soil the way you would break a horse or break an animal, and that's what they did. They broke it.
The demand and the price for wheat remained high throughout the 20s. Prosperity and good weather produced bumper crops. In fact, farmers saw a record wheat crop in 1930. Unfortunately, the stock market had crashed the previous October, and rural farmers were about to reap what Wall Street had sown. The bottom fell out, and wheat went from $1 a bushel to 25 cents. It now cost more to grow wheat than to sell it, so farmers stopped growing, and fields lay fallow. Then the rains dwindled. In a semi-arid environment, this was disaster. With acres of dry fields, prairie grassroot systems plowed under, and no rain on the horizon, the winds that whipped out of the Rockies blew up great storms of dust.
Anyone who ever lived through it can tell you about it. The really frightening thing of having darkness at midday, they would wet bandanas or wet cloths or towels and put them over their face like this to screen out the dust so you weren't breathing that stuff in. People died of what they called the Dust Bowl pneumonia, breathing in that dust.
The drought continued for months, then years. Finally, families began leaving, abandoning their farms, and heading for kin in other states, or just seeking out the hope of something better somewhere else. But most stayed and suffered because they knew of nowhere to run.
dust would blow in through the keyhole. So you wanted to get those wet towels and rags down to dust-proof your house. And of course, it was never possible. It would get in the chimney, it would get in through somewhere or other. And so whenever you went into your house, the damn stuff was all over. You'd rub a table and your hand would be dirty.
Some counties in southwest Kansas had lost nearly half their population. Abandoned, uncultivated fields only fed the dusty winds. Earth that took thousands of years to create blew away in minutes.
To have dust everywhere, know that you could never win that fight, that there was going to be dust all through your body, all through your clothing, through your food, that you couldn't escape it. It must have been a nightmare.
By 1934, over 650,000 tons of topsoil had blown away. After 10 years of unrelenting drought, dust, and depression, it ended. The rains came back. The rain made the soil less likely to blow. Grasses grew back in the dormant fields. Another world war soon raised the demand and the price for wheat. Prosperity returned to the Great Plains. But the farmers were determined to figure out why the Dust Bowl had occurred and what they could do to keep it from ever happening again. Beginning in the 1940s, the Wind Erosion Research Unit, located in Manhattan, Kansas, and part of the U.S. Department of Agriculture, has been doing just that.
I think our unit exists because of the Dust Bowl. The Dust Bowl was instrumental in creating the Soil Conservation Service. It was dust settling in Washington from the Great Plains.
The unit studied the causes of drought and the mechanics of dust storms.
So our mission is to understand the processes of wind erosion, develop predictive tools and control practices, and then transfer this technology to the people who need and use it.
The Wind Erosion Unit advised farmers on soil conservation techniques, from how to prepare the earth to which direction to plant crops, even how to till their fields.
Wind erosion is more susceptible when the soil is dry. However, soil will be very dry even in a 90% humidity. The atmosphere is not nearly as important as the humidity of the soil.
During the worst of the Dust Bowl, it was easy to blame farmers and their tractors for the environmental disaster. Many farmers sought ways to prevent a repeat of the dirty 30s. They terraced their fields in order to conserve water. They rotated their crops to prevent depleting the soil. They developed irrigation systems to stave off drought. They planted trees as barriers against the wind. And they didn't use their tractors as intensely as before. Low and no tillage farming came into vogue. Now farmers would work with nature because ultimately nature is too big to break. The 1950s saw the return of drought. The skies again filled with dust, but this time the farmers were better prepared. New farming techniques saw them through the filthy 50s and the droughts that would follow. In the meantime, the government began buying up vacant land and returning it to grasslands.
Or they would buy back 160 acres at a time and let it go back to the prairie grass and the prairie dogs and to the antelope and the deer.
The plow wasn't the only factor that contributed to the Dust Bowl of the 1930s, nor were farmers culprits, solely responsible for turning the land to dust. Today we better understand natural cycles and economic ones. Farmers no longer bust the sod. They work it, they nurture it, and they support it, as it helps support them. And when they do plow the land, they do so with the knowledge and experience learned from those dusty, windswept, and desolate days.
Though plows disturb roughly 1.5 trillion tons of earth annually, the majority of this soil is only moved a few inches, with roughly 1% lost to erosion. Construction machines will return in a moment on Modern Marvels.
Humans are moving dirt all over the planet at an unprecedented rate. Technology now allows us literally to alter the face of the earth.
We are moving about 3.8 billion tons of earth a year in mining operations, about 3 billion tons in road construction, and maybe 800 million tons in house construction. So that adds up to about 7.5 billion tons a year of earth being moved in the United States.
In fact, we are destroying Earth faster than it can be replaced. Yes, soil is made every day, created by seismic and environmental factors such as wind, gravity, rain, decay. And it is destroyed by the same factors. Rivers wash soil into the oceans. Wind blows dust into the atmosphere.
800 years ago, according to my estimates, the rate of human earth moving doubled in about 400 years. Now it has tripled in the course of about 25 years.
In fact, we may literally run out of Earth. As humans put greater burdens on the soil to support our ever-increasing population, we may have no place else to turn but up.
Eventually, life is going to leave the Earth, and I think the first step in leaving the Earth is going to be Mars. Now, right now, Mars is too cold and dry to support any life from Earth.
Earth movers, or in this case, Mars movers, may change all that. The fourth planet from the Sun is about 1/2 the size of Earth, has 4 distinct seasons, 24.5-hour days, and a mean temperature of minus 81 degrees Fahrenheit.
But if we were to warm it up just a bit, then we can imagine seeding plants and ultimately taking animals to Mars.
But there's a bigger problem on Mars than just the chill.
The real problem for life on Mars is that there's no liquid water. Nowhere on the planet at any time is water a liquid. Now there's ice and there's vapor, but it's never liquid.
Carbon-based life forms like humans and plants need liquid to survive. How do you turn ice and vapor into liquid water on Mars? Enter Mars movers.
To make Mars warmer, to make Mars a little bit wetter, will require some kind of machines that we would send to Mars that would generate the conditions which would ultimately allow biology. You can think of those machines as sort of like gardening tools that get the ground ready so that we can introduce life.
These machines, which might resemble this vehicle designed to explore asteroids, would drive over the surface of the planet, scooping up soil and processing greenhouse gases such as carbon dioxide, the elements of which exist in the soil naturally, so that they can be released into the thin Martian atmosphere.
So the dirt becomes a feedstock, becomes material that these machines scoop up and process, extracting the molecules needed to make these super greenhouse gases.
These Earth movers would help build a Martian atmosphere that was thicker and warmer, enough to melt frozen ice on Mars into water. Eventually, the planet might be warm enough to introduce plants. Then, after the plants have transformed carbon dioxide into oxygen, human colonization might come next. But the first challenge would be getting the Earth movers onto Mars.
What I would propose we do is size them big enough that they could be launched on a single rocket. That's why they would probably be about the size of an automobile. Land on Mars, open up their solar panels, and start doing their thing, eating Mars dirt and releasing greenhouse gases, making Mars warmer.
Operated remotely from Earth, they would be monitored and checked for reckless driving.
If we were driving a vehicle on Mars, remote controlling from Earth, and we hit the brakes on Earth, it would take about 4 to 20 minutes before the vehicle stopped on Mars, depending on where Mars is in its orbit.
Our Mars Earth movers would have some onboard intelligence which could warn them against driving into boulders or off a cliff. From Earth, 2 people might remote control a fleet of 50 or 100.
Someday, after Mars is warm and there's forests and people walking around, there will be museums, and in the museum they might have the very first of these vehicles that ever went to Mars to make the greenhouse gas and say that this is what started it all. And maybe it'll still be working.
Some scientists speculate that day might come within the next 100 to 200 years. Only one problem.
Well, we don't know exactly how we'd take Mars soil and make the compounds we need. It's not theoretically impossible. It's just someone's got to come up with a clever way to do the chemistry.
Maybe someday some Martian farmer will glance up over his shoulder at the big blue planet and be thankful that we learned so much about Earth moving back when we lived only on the Earth. Assuming Earth isn't blown apart by a collision with an asteroid. Scientists speculate putting Earth movers to work to deflect these giant space neighbors.
We think there's anywhere from 1,000 to 2,000 objects about a mile in diameter or larger that are within the Earth's neighborhood.
But it's a big neighborhood. Scientists define near-Earth objects as those that get within roughly 30 million miles of Earth's orbit. Nevertheless, something a mile across hitting the Earth would be cataclysmic.
The last large impact on the Earth probably took place 65 million years ago, when the dinosaurs were wiped out by an object that was 6 miles in diameter and struck near the Yucatan Peninsula.
But don't worry. The number of large near-Earth objects is small, and scientists expect to hit only every 100 to 200,000 years.
So the object is to try and find the vast majority of these objects and keep an eye on them.
If they spy one headed in our direction, Earth movers will likely be ready to save the day. Scientists have already theorized some strategies for dealing with these monsters from outer space, including the most powerful Earth mover ever created, a hydrogen bomb.
The most direct and probably the most efficient way of doing it would be to set off a nuclear weapon, not to blow it up, but simply to set it off near the surface of the asteroid so the neutron flux from this neutron bomb would ablate the front side of the asteroid and form a rocket-like thrusting of the material off the surface. And if we can give the asteroid just a tiny thrust, maybe a centimeter per second or so, over the 10 or 20 years that it would take for this asteroid to impact Earth, we would have moved it enough so that it would miss Earth.
Or scientists could attach the engine of the space shuttle to the asteroid and drive it away. Or erect a giant solar sail that catches sunlight and pushes the asteroid. Or even attach a digging device that throws rocks into space, creating a recoil that throws the asteroid into a different orbit. But attaching things to asteroids can be slippery.
One of the problems we have is that there's so little gravity that it's almost like driving your car on Earth on sheet ice.
Anchoring devices onto asteroids is one of the challenges scientists feel confident they can solve before any detected near-Earth object comes plummeting towards Earth. In fact, we may choose to mine asteroids and comets for minerals and fuels as we begin to colonize the inner solar system. All sorts of new Earth movers are on the drawing board, both for our own planet and for those yet to be explored. What began as a simple effort to keep us sheltered and fed has turned into an engineering legacy that is a hallmark of the modern age, for good or ill. We humans are the Earth movers, designing bigger trucks and scoops and drills, moving Earth and moving beyond Earth into a frontier limited only by the scope of our imagination and our ability to build what we see there.